The observable universe stretches over 93 billion light-years across, filled with galaxies, stars, and planets. But here's the twist: what we can see might just be the tip of the cosmic iceberg. Beyond the boundaries of our observable reach lies a vast, uncharted expanse, a mystery that defies comprehension. What's out there? Are there infinite universes, dimensions we can't perceive, or realities that challenge everything we think we know? This question isn't just about space, it's about the very nature of existence. Today, we're diving into the theories that attempt to answer what lies beyond the observable universe. From the multiverse to cosmic bubbles, these ideas will stretch your imagination and leave you questioning the fabric of reality. So, are you ready to step into the unknown and explore the edges of what we can and can't see? Let's begin. When we gaze up at the night sky, what we're seeing is just a fraction of the cosmos, a window into what we call the observable universe. This is the part of the universe we can detect, shaped by two fundamental constraints: the speed of light and the age of the universe itself. Light from distant stars and galaxies takes time to travel across the vastness of space, and because the universe is about 13.8 billion years old, we can only see as far as light has had time to reach us. This creates a boundary, a cosmic horizon, marking the edge of what's visible to us right now. Think of it like standing on a beach looking out at the ocean. The horizon you see isn't the end of the water. It's just as far as your eyes can reach. In the same way, the cosmic horizon isn't the edge of the universe. It's simply the limit of what we can observe. Beyond this boundary lie galaxies and structures whose light hasn't had enough time to reach us yet. And then there's the cosmic microwave background, the faint afterglow of the Big Bang, which acts like a snapshot of the universe when it was just a hot, dense soup of particles. This is often described as the edge of the observable universe, a remnant of the earliest moments of existence. But here's the intriguing question: what lies beyond this? If the observable universe is like a spotlight illuminating only a small corner of a vast stage, what's hiding in the shadows? The answer to that question isn't just about what's out there, it's about understanding the nature of the universe itself. Are there infinite galaxies stretching endlessly into the void? Are there structures or phenomena that defy our current understanding of physics? Or could there even be other universes entirely separate from our own, lying just beyond our cosmic horizon? These are the mysteries that beckon us to look further, to explore what might lie beyond the limits of what we can see. As we dive deeper into these questions, we'll uncover theories that challenge our understanding of reality and push the boundaries of science itself. From the possibility of a multiverse to the mind-bending concept of cosmic inflation, the universe beyond our observable view holds secrets that could reshape everything we think we know. And while we may not have all the answers yet, the journey to uncover them is as thrilling as the discoveries themselves. As we gaze deeper into the cosmos, we encounter a fascinating and somewhat humbling concept: the cosmic horizon. This invisible boundary marks the edge of what we can observe. It's not a physical wall, but rather a limit imposed by the vast distances and the relentless expansion of the universe. To understand this, picture a ship sailing across the ocean. As it moves farther away, it eventually dips below the horizon, disappearing from view. Something similar happens in space, but on a cosmic scale. Here's where it gets even more mind-bending. The universe is expanding, and galaxies are moving away from us at incredible speeds. In fact, some are receding faster than the speed of light. While nothing can surpass the speed of light within space, the expansion of space itself allows this to happen. This means that light from these distant galaxies will never reach us, effectively placing them beyond our cosmic horizon. Our current technology, as advanced as it is, simply can't overcome this barrier. Telescopes can peer billions of light years into the cosmos, but there's a limit to what they can capture. This leaves us with a tantalizing question: what lies beyond that horizon? Could the universe be vastly different in ways we can't yet imagine? Perhaps regions beyond our view hold entirely new laws of physics or forms of matter. For now, it remains one of the great mysteries of the cosmos, inviting us to keep exploring and questioning. What if our universe is just one of many? The multiverse theory is one of the most fascinating ideas about what might exist beyond the edges of what we can see. This concept suggests that our universe isn't alone. Instead, it's part of a vast, possibly infinite collection of universes, each with its own unique set of physical laws and constants. Picture a cosmic ocean filled with bubbles where each bubble represents a separate universe. Some might have gravity, others might not. Some might be teeming with life, while others could be utterly barren. This isn't science fiction. It's a serious scientific proposal rooted in quantum mechanics and inflationary cosmology. Quantum mechanics, the science of the very small, hints that particles can exist in multiple states at once until observed. Inflationary cosmology, on the other hand, suggests that the universe expanded exponentially in its earliest moments, creating regions that could have developed independently, forming separate universes. Together, these ideas paint a picture of a multiverse that's as mind-bending as it is plausible. But what kinds of multiverses could exist? Are they all similar to ours, or do they vary wildly in their structure and rules? That's where things get even more intriguing. Up next, we'll dive into the different types of multiverses that scientists speculate about, each one more astonishing than the last. Stay tuned. So, what lies beyond the edges of our observable universe? Many scientists believe the answer might lie in the idea of the multiverse, a vast, interconnected web of universes beyond our own. And within this concept, there are several intriguing types to explore. One of the most fascinating is the bubble multiverse. Picture our universe as a single bubble floating in a cosmic sea of foam with countless other bubbles, each representing its own universe existing alongside it. This theory, rooted in the concept of eternal inflation, suggests that new universes are constantly being born, each with its own unique set of physical laws. Imagine a universe where gravity is 10 times stronger, or where stars never form. These are the kinds of possibilities the bubble multiverse opens up. Then there's the brain multiverse, a concept that emerges from string theory. In this model, our universe exists on a multidimensional membrane, or brain, floating in a higher dimensional space. Other brains, each hosting its own universe, could be floating just out of reach, separated by dimensions we can't perceive. Think of it like pages in a book. Each page is a universe, and the book itself is the multiverse. This theory not only hints at the existence of parallel realities, but also suggests that collisions between brains could explain cosmic events like the Big Bang. Finally, we have the quantum multiverse, a mind-bending idea that arises from quantum mechanics. According to this theory, every time a quantum event occurs, like the decay of an atom, the universe splits into multiple realities, each representing a different outcome. In one universe, you might have turned left at a crossroads, while in another, you turned right. These parallel universes branch off endlessly, creating an infinite tapestry of possibilities. It's a concept that challenges our very understanding of cause and effect, suggesting that every decision we make spawns an entirely new reality. These theories aren't just abstract ideas. They're supported by cutting-edge science, from string theory's mathematical elegance to quantum mechanics' experimental precision. They force us to rethink what we know about reality, opening up questions about existence, meaning, and the nature of the cosmos. But here's the real kicker: could we ever detect evidence of these other universes? Some scientists believe we might, through subtle imprints left on the cosmic microwave background or through anomalies in the behavior of particles. The search for these clues is ongoing, and the answers could fundamentally change how we see the universe and ourselves. What if our universe isn't alone? The idea of a multiverse where countless other universes exist alongside ours might sound like science fiction, but there's growing scientific interest in finding evidence to support it. One intriguing clue comes from anomalies in the cosmic microwave background, the faint glow left over from the Big Bang. Some researchers believe that unusual patterns in this radiation could hint at collisions between our universe and others, like cosmic fingerprints left behind. These anomalies spark questions about whether our universe once bumped into its neighbors in a vast multiverse. Another piece of the puzzle lies in the fine-tuning of physical constants. Why do the laws of physics seem so perfectly calibrated to allow for life? Some scientists argue that if there are countless universes, each with its own set of physical rules, it's statistically inevitable that one like ours would emerge. It's like rolling a die an infinite number of times. Eventually, you'll land on the perfect combination. But proving the multiverse is no easy task. Scientists are also searching for gravitational waves, ripples in space-time that could carry signals from other dimensions or universes. These waves might offer a glimpse into realms beyond our own, but detecting them requires incredibly sensitive technology. The challenge is that even if these signals exist, they could be incredibly faint or buried in the cosmic noise. Despite these hurdles, the search continues, driven by curiosity and the desire to understand the true nature of reality. Yet, the multiverse might not be the only explanation. Could there be other theories, equally mind-bending, that explain what lies beyond our observable universe? Exploring this question takes us even deeper into the mysteries of existence. What if the universe never ends? This is the central idea behind the infinite universe theory, a concept that challenges our understanding of space and existence. According to this theory, the universe isn't just vast, it's truly boundless, stretching endlessly in every direction. This idea isn't just philosophical speculation, it's supported by observations of the universe's geometry. Measurements from cosmic microwave background radiation suggest that the universe is flat, meaning it could extend infinitely without curving back on itself. If that's true, the implications are staggering. An infinite universe could contain infinite possibilities. Think about it, somewhere out there, there could be countless Earths, countless versions of you, and even worlds so bizarre they defy imagination. To wrap your head around this, picture an infinite library. Each book represents a unique universe with its own set of physical laws and histories. In such a library, every possible story exists, every event, every outcome. Now scale that up to reality. If the universe is infinite, then every configuration of matter, every combination of atoms must exist somewhere. This leads to mind-bending possibilities like duplicate Earths with nearly identical versions of us, or alien civilizations so advanced they've mastered the cosmos. But here's the question, is infinity a scientific concept or a philosophical one? On one hand, infinity can be described mathematically and supported by observations. On the other, it stretches beyond what we can ever observe or prove, pushing us into the realm of abstract thought. This tension between science and philosophy makes the infinite universe theory one of the most fascinating ideas in cosmology, a theory that doesn't just expand our understanding of space but challenges us to rethink our place within it. As we peer into the vastness of the cosmos, one question looms large. What shape is our universe? It might sound strange to think of the universe as having a shape, but scientists have been grappling with this idea for decades. The most widely accepted models suggest three possibilities: flat, spherical, or hyperbolic. Each of these shapes carries profound implications for the nature of our universe, whether it's finite or infinite, and even how it might end. Imagine the universe as a flat sheet of paper stretching endlessly in all directions. A flat universe would mean parallel lines stay parallel forever, and the geometry we learn in school holds true on the grandest scale. But what if the universe curves? Picture it as the surface of a balloon where space bends back on itself. In a spherical universe, if you traveled far enough in one direction, you'd eventually return to your starting point, much like circumnavigating the globe. Then there's the hyperbolic model, where space curves outward in a saddle-like shape, expanding in ways that defy our everyday intuition. The shape of the universe isn't just a matter of abstract geometry, it's deeply tied to its contents. Dark energy, that mysterious force driving the universe's accelerated expansion, and dark matter, the invisible scaffolding holding galaxies together, play pivotal roles in determining its curvature. If dark energy dominates, the universe might stretch into a flat or hyperbolic shape, expanding forever. But if matter and energy are dense enough, the universe could curve into a closed, spherical form. To visualize this, think of a balloon being inflated. As it grows, every point on its surface moves away from every other point. In a similar way, our universe is expanding, but the fabric of space itself might not be flat. The shape of that fabric holds secrets not just about our universe, but about what might lie beyond its observable edges. Could the universe's curvature hint at other dimensions or even parallel universes? As we explore these ideas, we're reminded that the cosmos is far more intricate and mysterious than we ever imagined. What if the Big Bang wasn't the absolute beginning, but just one moment in an infinite series of cosmic events? The Big Bang is often seen as the explosive birth of our universe, but some scientists suggest it might not be a singular event. Instead, it could be part of a much larger, cyclical process, a pattern of creation and destruction that repeats over and over. Imagine the universe as a cosmic heartbeat, expanding with each Big Bang and contracting into a big crunch, only to start again. This idea of a cyclic universe challenges our understanding of time and existence, hinting that what we see as the beginning might simply be a single chapter in an unimaginably vast story. If this theory holds, it opens the door to a mind-bending possibility. Other universes could have existed before ours, and more might follow after. Each cycle could birth entirely new cosmic landscapes with different laws of physics, dimensions, or even life forms. The remnants of these past universes might still linger, hidden in the fabric of space itself. Could ancient echoes of their existence be found in the cosmic microwave background or the distribution of galaxies? It's a tantalizing thought, one that invites us to rethink not just where we came from, but where we might be headed in the grand cosmic dance. Picture this, a universe so vast, so infinitely expanding, that it's almost impossible to fathom. But what if I told you our universe might be just one tiny bubble in an endless cosmic ocean? This is where the theory of cosmic inflation comes into play. In the very first moments after the Big Bang, the universe didn't just expand, it exploded outward at an unimaginable speed, like a balloon inflating faster than the blink of an eye. This exponential growth is called cosmic inflation, and it's one of the most fascinating ideas in modern cosmology. Now, here's where it gets even more mind-bending. During this rapid expansion, it's possible that different regions of space-time expanded at slightly different rates. These variations could have created what scientists call pocket universes, separate, self-contained regions with their own unique physical laws. Imagine each of these pockets as bubbles in a champagne glass, each one a universe unto itself, but all originating from the same cosmic event. But the story doesn't stop there. Some cosmologists propose that this process of inflation never truly ends. This is the concept of eternal inflation, a theory suggesting that while our universe may have settled into a stable state, other regions of space-time continue to expand exponentially, creating an infinite number of new universes. It's like a never-ending fireworks display in the night sky, where every spark ignites a new universe, each one flickering into existence in its own corner of the cosmos. And here's the kicker: if eternal inflation is true, it means that right now, as you're watching this, there could be countless other universes being born, each one governed by its own set of physical rules. Some might have stronger gravity, weaker nuclear forces, or even more dimensions than we can perceive. The idea that we're living in just one of an infinite multiverse is both humbling and exhilarating, opening up possibilities that challenge everything we think we know about reality. So, what does this mean for us? Could there be a universe out there where the laws of physics allow for perpetual motion machines, or where time flows backward? The answers might seem as distant as the stars themselves, but the journey to uncover them is what makes cosmology so thrilling. And as we ponder these questions, we're reminded just how vast and mysterious the cosmos truly is, not just beyond our observable universe, but in the very fabric of existence itself. What if everything we perceive as reality, our three-dimensional world with all its depth and complexity, is nothing more than a projection? This is the mind-bending idea at the heart of the holographic principle. Born from the strange and counterintuitive world of black hole physics and string theory, this concept proposes that the universe might not be what it seems. Instead of a vast three-dimensional expanse, it could be a holographic projection originating from a two-dimensional surface. Think of it like the hologram on a credit card, flat at first glance, but when you tilt it, it reveals depth and movement. In the same way, our universe could be a kind of cosmic illusion, with all its richness encoded on a two-dimensional boundary we can't directly perceive. Black holes play a key role here. When matter falls into a black hole, its information isn't lost but is thought to be stored on the event horizon, the boundary that marks the point of no return. This led physicists to wonder, could the entire universe work the same way? If so, the nature of space-time itself might be fundamentally different from how we've always understood it. Rather than a solid, tangible fabric, it could be more like a holographic interface with the true reality existing in a realm we can't see. The implications are staggering. If the holographic principle holds, it could reshape our understanding of everything from gravity to the very structure of reality. So, could the universe be a cosmic hologram? It's a question that challenges not just science, but our perception of existence itself. Picture this, an invisible force silently at work, stretching the fabric of the universe like an endless balloon. That force is dark energy, and it's one of the greatest mysteries in modern cosmology. Unlike gravity, which pulls objects together, dark energy does the opposite, it pushes. This enigmatic energy is causing our universe to expand at an accelerating rate, driving galaxies farther apart like leaves caught in an unseen cosmic wind. But what exactly is dark energy, and how could it shape the ultimate fate of everything we know? Scientists believe dark energy makes up about 68% of the universe, yet we've only detected it indirectly through its effects. It's as if we're trying to understand a storm by watching how the trees bend without ever seeing the wind itself. This mysterious force raises profound questions. Will the universe continue to expand forever, growing colder and emptier as dark energy dominates? Or could this expansion lead to something even more unexpected, like a connection to other universes? Which brings us to the multiverse theory. Some researchers speculate that dark energy might play a role in the existence of parallel universes. If our cosmos is just one bubble in a vast cosmic foam, dark energy could be the force that inflates these bubbles, separating them from one another. It's a staggering idea that the very energy driving our universe apart might also be creating entire realities beyond our own. Think of dark energy as the conductor of an orchestra, guiding the movements of galaxies and shaping the rhythm of the cosmos. Without it, the universe would look completely different. And while we're still far from fully understanding its nature, one thing is clear. Dark energy might hold the key to unlocking the deepest secrets of existence. What happens when the universe reaches its final act? The answer isn't just about endings, it's about the profound possibilities that lie beyond. One of the most widely discussed theories is the Big Freeze, also known as heat death. In this scenario, the universe continues to expand indefinitely, growing colder and darker as stars burn out and galaxies drift further apart. Imagine a cosmos where light fades into endless blackness and all energy is spread so thinly that everything comes to a standstill. It's a haunting vision, but it's not the only one on the table. On the other hand, the Big Rip presents a more dramatic finale. Here, the expansion of the universe accelerates so rapidly that it tears apart everything: galaxies, stars, planets, even atoms. Picture a cosmic force so powerful that it rips the fabric of reality itself, leaving nothing but void in its wake. It's a scenario where the universe doesn't just fade, it shatters. Then there's the Big Crunch, a stark contrast to the other two. In this theory, the universe's expansion slows, stops, and reverses, collapsing back into a singularity, a single point of infinite density. It's like a cosmic rewind button where everything that ever existed is compressed into a pinprick of space and time. Some scientists even speculate that this could trigger another Big Bang, creating a new universe in an endless cycle of birth, death, and rebirth. These theories aren't just about how the universe ends, they're about what comes next. Could the end of our universe be the beginning of something entirely new? Might the Big Crunch spawn a fresh cosmos, or could the Big Freeze leave behind a canvas for entirely unknown phenomena? The answers to these questions could reshape our understanding of existence itself. And while we may not live to see it, the beauty lies in the mystery, the idea that even in its final moments, the universe might hold the key to infinite possibilities. At the heart of many cosmic mysteries lies the enigmatic black hole, an object so dense that not even light can escape its gravitational pull. But could these cosmic behemoths be more than just destructive voids? Some scientists propose that black holes might serve as gateways to other universes or dimensions, offering a tantalizing possibility for what lies beyond the observable cosmos. This idea is rooted in the concept of wormholes, theoretical passages through space-time first proposed by Albert Einstein and Nathan Rosen. Known as Einstein-Rosen bridges, these hypothetical tunnels could connect distant regions of the universe or even different universes entirely. Think of it as a cosmic subway system where black holes act as entrances to tunnels that shortcut through the fabric of reality. While the math supports the possibility of wormholes, the extreme conditions inside black holes make testing these theories incredibly challenging. The intense gravitational forces and the presence of a singularity, a point of infinite density, create an environment that defies our current understanding of physics. Yet, the idea persists, fueled by the tantalizing thought that within the depths of a black hole, entire universes could be hidden, waiting to be discovered. What if everything we know, our universe, our reality, isn't what it seems? Enter the simulation hypothesis, a theory that proposes our entire existence might be nothing more than an incredibly sophisticated computer simulation created by an advanced civilization. This idea isn't just science fiction, it's a serious possibility that some scientists and philosophers have explored. Think of it like living inside a video game where everything you see, touch, and experience is a product of intricate code running on a system far beyond our understanding. The boundaries of our observable universe might not be the ultimate limits, they could just be the edges of the simulation, with a vastly different, real universe existing outside it. This theory raises profound questions about the nature of reality. If we are living in a simulation, what does that say about free will, consciousness, or even the purpose of our existence? Philosophers have debated these ideas for centuries, but the simulation hypothesis gives them a modern twist. From a scientific perspective, some researchers have even proposed ways to test this theory, such as looking for glitches or patterns in the fabric of reality that might hint at a programmed universe. But let's take a step back. If our universe is a simulation, what does that mean for what lies beyond? The real universe could operate under entirely different laws of physics, with dimensions and phenomena we can't even begin to comprehend. It's a mind-bending thought. The cosmos we're observing might just be a tiny, artificial construct within a much grander, unknown reality. So, could we ever prove we're living in a simulation? It's a question that challenges both our scientific tools and our philosophical frameworks. Even if we find evidence, it might be impossible to fully grasp the true nature of the creators or the reality beyond our simulated existence. This theory doesn't just expand our understanding of the universe, it completely redefines it, forcing us to confront the possibility that everything we know might be part of an elaborate cosmic program. It's easy to assume that what we see, hear, and measure is the full picture of the universe, but the truth is far more humbling. Our human senses and even the most advanced technology are limited to perceiving only a tiny slice of reality. Think of it this way: the electromagnetic spectrum spans everything from radio waves to gamma rays, but our eyes can detect just a narrow band of it visible light. That means we're blind to the vast majority of energy and information swirling around us, and it's not just light. Our ears can't hear sounds below 20 Hz or above 20,000 Hz, leaving entire ranges of vibrations undetected. Even our instruments, though extraordinary, have their boundaries. Telescopes peer billions of light years into space, but they're still constrained by the laws of physics. We can't observe what lies beyond the observable universe because the light from those regions hasn't had time to reach us. And what if there are dimensions or forces that exist completely outside our understanding? Our tools are built to measure only what we already know exists, leaving the possibility that entire aspects of reality remain hidden. This raises a profound question. What if the true nature of the universe is something we're simply not equipped to perceive? Just as a fish might not comprehend the concept of land, our brains might lack the capacity to fully grasp what lies beyond our observable limits. It's a humbling thought, one that challenges us to consider how much of reality might always remain beyond our reach. Mathematics is often called the language of the universe, and for good reason. It's the tool that allows us to decode the cosmos, translating its mysteries into equations and patterns we can understand. When it comes to exploring what lies beyond the observable universe, mathematics is our compass, guiding us through realms that defy human intuition and imagination. Take string theory, for example. This ambitious framework suggests that the fundamental building blocks of the universe are not particles but tiny, vibrating strings. To describe this, mathematicians use complex equations that weave together dimensions far beyond the three we experience daily. Similarly, M-theory, a broader extension of string theory, posits the existence of 11 dimensions. These theories are built entirely on mathematical foundations, offering glimpses into realities that our senses could never perceive. Think of mathematics as a cosmic language. Just as words can describe the world around us, equations can map out the behavior of stars, galaxies, and even the fabric of space-time itself. But this language goes further. It can describe things we can't see or touch, like parallel universes or higher dimensions. It's like trying to explain the color red to someone who's never seen it. Mathematics bridges that gap, allowing us to conceptualize the inconceivable. And it's not just about describing what we know, it's about predicting what we don't. Mathematical models have led to discoveries like black holes and gravitational waves long before we had the technology to observe them. So, could math reveal the true nature of the universe? It's a question that has intrigued scientists for centuries. While mathematics has proven to be an incredibly powerful tool, it's important to remember that it's a language built by humans, shaped by our understanding and limitations. Yet, its ability to describe and predict phenomena with such precision suggests that it might be more than just a human invention. It could be a window into the fundamental truths of existence. As we continue to explore the unknown, mathematics will undoubtedly remain our most trusted guide, helping us unravel the secrets of what lies beyond the observable universe. Time is something we all experience, but what if it works completely differently beyond the edges of our observable universe? Here on Earth, we think of time as a linear progression, a straight line from the past through the present and into the future. But beyond our cosmic horizon, time might not follow the rules we're used to. One fascinating theory is eternalism, which suggests that past, present, and future all exist simultaneously. Picture it like a vast tapestry where every moment in history is woven together, fixed and unchanging. Instead of time being a march forward, it's more like a landscape with every event eternally present in its own place. Now imagine a river. Here it flows in one direction, but what if, in another universe, that river splits into countless streams, each moving in a different direction? This metaphor helps us grasp how time might behave in other dimensions or parallel universes, breaking free from the single, steady flow we know. In some theories, time could loop back on itself or even move in multiple directions at once. It's a mind-bending idea, but it raises the question, could we ever harness this flexibility to travel through time? And if so, what would that mean for the existence of alternate timelines where every decision spawns a new reality? As we gaze into the infinite expanse of the cosmos, a question lingers in the minds of scientists and dreamers alike: where is everyone? This is the heart of the Fermi Paradox, a puzzle that challenges our understanding of the universe. With billions of stars and galaxies, some with planets in habitable zones, why haven't we encountered any signs of intelligent life? It's as if the universe is playing a cosmic game of hide and seek, with the rules just out of reach. One possible explanation ties directly into the mysteries beyond the observable universe. Perhaps civilizations exist, but they're not where we're looking, or even how we're looking. Imagine life thriving in dimensions we can't perceive, or in alternate universes beyond the reach of our telescopes. These realms could be teeming with beings and cultures, yet invisible to our current understanding of physics. It's like trying to hear a song played on a frequency our radios can't pick up. This paradox also raises the possibility that advanced civilizations might have evolved beyond our comprehension, existing in ways we can't yet fathom. Are they hidden in plain sight, or are they simply operating on a scale that transcends our limited perception? These questions push us to reconsider not just where life might be, but what it could be. And as we ponder the vastness of the cosmos, one thing becomes clear: the universe holds secrets far beyond our current grasp. Could it be that other universes, parallel or otherwise, are bustling with life, waiting for us to uncover the keys to their existence? The Fermi Paradox doesn't just challenge us to find answers, it invites us to expand our imagination and explore the infinite possibilities that lie beyond the stars. What if the universe isn't just something we observe, but something that observes itself? This thought leads us to the intriguing idea that consciousness might not just be a byproduct of the cosmos, but a fundamental part of its fabric. Theories like panpsychism propose that consciousness is woven into the very essence of reality, present in everything from the tiniest particles to the vastest galaxies. It's a radical shift from seeing consciousness as something that emerges from complex brains to viewing it as a universal property, as inherent as space or time. Imagine the universe as a living, self-aware entity. In this metaphor, every star, planet, and galaxy isn't just a passive object, but a participant in a grand cosmic awareness. This perspective challenges us to rethink our place in the cosmos. Instead of being mere observers, we might be active contributors to the universe's unfolding story. If consciousness is indeed foundational, it could mean that reality is shaped not just by physical laws, but by the act of perception itself. Think about how this idea could transform our understanding of the cosmos. If consciousness is a fundamental aspect of the universe, then exploring the unknown might not just be about mapping distant galaxies or unraveling the mysteries of dark matter. It could also involve probing the nature of awareness itself. Could consciousness be the key to unlocking some of the universe's deepest secrets? Could it help us bridge the gap between what we can observe and what lies beyond? This line of thought opens up fascinating possibilities. It suggests that the answers to cosmic mysteries might not lie solely in the outward exploration of space, but also in the inward exploration of the mind. As we continue to push the boundaries of our knowledge, consciousness could be the lens through which we finally glimpse what lies beyond the observable universe. Imagine listening to the cosmos, scanning the endless static of the universe for a whisper of something, anything that doesn't belong. This is the heart of the search for extraterrestrial intelligence, or SETI, an ambitious effort to detect signals from civilizations beyond our own. For decades, researchers have trained radio telescopes on the stars, hoping to catch a deliberate message or even an accidental broadcast from an alien society. But what if the answer isn't just out there in the stars, but perhaps beyond the very fabric of our universe? SETI mission has evolved over time. While the initial focus was on scanning our observable universe, the search has expanded to include possibilities that stretch the limits of our imagination. Some researchers now speculate about detecting signals from other dimensions or parallel universes, realms that might exist just beyond our perception. The idea is both thrilling and daunting. If life exists in these places, could it reach out to us? And if it did, would we even recognize it? Take the famous WOW signal, for example, detected in 1977. This brief burst of radio waves seemed to defy explanation. It was strong, clear, and seemingly artificial, leaving scientists both excited and puzzled. Decades later, its origin remains a mystery. Was it a cosmic coincidence, a glitch in the equipment, or just maybe a message from another civilization? The WOW signal is a reminder of how challenging this search truly is. The universe is vast, and the odds of finding a needle in a cosmic haystack are slim. Yet, it's precisely this challenge that keeps the search alive. The question is no longer just whether we're alone in our universe, but whether we're alone in the multiverse. Could a signal from beyond our observable universe, from a realm we can't even see, reach us? It's a mind-bending thought, one that pushes the boundaries of science and philosophy alike. As we continue to listen, the cosmos remains silent, its secrets hidden in the static. But who knows, one day the static might part and we'll hear something extraordinary. Something that changes everything. When we think about the universe, we often picture vast galaxies, swirling nebulae, and the steady march of time. But beneath this cosmic tapestry lies a realm so strange, it defies everything we know about reality. Enter quantum mechanics, the science of the very small, where particles don't follow the rules we're used to. Here, the familiar laws of physics break down, and the universe begins to feel more like a dream than a clockwork machine. At this scale, particles can exist in multiple states at once, a phenomenon called superposition. It's as if a coin isn't just heads or tails, but both simultaneously until you look at it. Then there's quantum entanglement, where particles become so deeply connected that changing one instantly affects the other, no matter how far apart they are. It's like two dancers on opposite sides of the universe moving in perfect unison, their steps synchronized by some invisible thread. These bizarre behaviors suggest that reality might have a deeper layer, one we're only beginning to glimpse. Could this hidden layer hold the key to understanding what lies beyond the observable universe? Some scientists believe quantum mechanics might be the bridge to the multiverse, a vast array of parallel worlds where every possible outcome of every decision plays out. Picture our universe as one note in an infinite cosmic symphony, with countless other universes harmonizing in ways we can't yet imagine. The quantum realm, with its strange rules and mysterious connections, hints at a reality far richer and more complex than we've ever dared to dream. And if that's true, the boundaries of what we call the universe might be just the beginning. what if nothingness is not as empty as it seems? When we think about the void beyond the observable universe, it's easy to picture a vast, empty expanse, a true nothingness. But the concept of nothing is far more fascinating and complex than it appears. In the realm of quantum physics, scientists have discovered that even in what we call a vacuum, particles pop into and out of existence in a phenomenon known as the quantum vacuum. This suggests that what looks like emptiness might actually be a seething sea of energy teeming with potential. Think of it like a blank canvas. At first glance, it's just an empty space, but with the right tools and creativity, it can become a masterpiece. In the same way, the quantum vacuum isn't truly empty. It's a dynamic, energetic foundation where particles emerge and vanish in a cosmic dance. This challenges our understanding of nothingness. If even the void is alive with activity, could it be the very fabric from which everything arises? Could nothingness be the foundation of everything? As we continue to explore the mysteries of the universe, this question reminds us that even the most ordinary-seeming concepts can hold extraordinary secrets. But what happens when science reaches its limits? That's where philosophy steps in, offering a different lens through which to explore the mysteries of the universe. Think of it like this: if science is the methodical process of assembling a cosmic puzzle, philosophy is the act of stepping back to question why the puzzle exists in the first place, or even if it's the only puzzle on the table. Philosophers have long grappled with questions that science alone can't answer, like the nature of reality itself. Take solipsism, for example, a concept that suggests the only thing we can truly know is our own consciousness. While it might sound abstract, this idea forces us to consider how much of the universe we perceive is real, and how much might be a construct of our minds. It's a thought experiment that echoes in modern cosmology, where theories about the multiverse or simulations challenge our understanding of existence. Philosophy doesn't just ask these questions, it provides frameworks for how we might approach them. It encourages us to think beyond the observable, to consider possibilities that might seem impossible at first glance. And in doing so, it complements science by pushing the boundaries of what we're willing to explore. Without philosophical inquiry, scientific discoveries might remain confined to what we can measure and test. Together, they form a dynamic partnership, each pushing the other to go further, to ask harder questions, and to dream bigger. So, while telescopes and equations help us map the cosmos, philosophy might just be the compass that guides us toward the next great discovery. Throughout history, humanity's fascination with the cosmos has been woven into the very fabric of our cultural and spiritual narratives. From the earliest creation myths to the sacred texts of world religions, the question of what lies beyond our observable universe has been a recurring theme. These stories, passed down through generations, reflect not only our ancestors' curiosity, but also their attempts to make sense of the vast, mysterious expanse above us. Take, for example, the Hindu concept of the cyclical universe, where creation, destruction, and rebirth occur in endless succession. A vision that intriguingly mirrors modern theories about the Big Bang and the potential for a multiverse. Similarly, in Norse mythology, the cosmos is depicted as a vast tree, Yggdrasil, connecting different realms of existence, an idea that resonates with today's discussions of interconnected dimensions. These ancient narratives often serve as a tapestry of beliefs, each thread representing a unique cultural perspective, yet collectively forming a larger picture of humanity's enduring quest for understanding. What's fascinating is how these mythological frameworks sometimes intersect with cutting-edge science. For instance, the idea of a universe emerging from a primordial void has echoes in both the Mayan Popol Vuh and contemporary cosmological models. Could it be that these ancient stories, born of imagination and wonder, hold subtle clues to cosmic mysteries we're only now beginning to unravel? While they may not provide scientific answers, they remind us that the search for what lies beyond has always been a deeply human endeavor, one that bridges the gap between the spiritual and the scientific. As we continue to explore the cosmos with telescopes and equations, perhaps it's worth pausing to consider the wisdom of those who first looked to the stars with awe and wonder. Art has always been humanity's way of painting the unseen, of giving form to the formless. When we look at the vastness of the universe and wonder what lies beyond, it's often through the lens of creativity that we begin to glimpse the unimaginable. Think of the cosmos as a canvas, infinite and unmarked, waiting for the brushstrokes of human imagination to bring its mysteries to life. From the earliest cave paintings to the most ambitious science fiction epics, art has served as a bridge between what we know and what we can only dream of. Science fiction, in particular, has played a pivotal role in shaping how we envision the unknown. Works like Star Trek or Interstellar don't just entertain, they inspire. They challenge us to ask questions, to ponder the possibilities of alternate realities, and to imagine technologies that could one day become reality. These stories don't just reflect our curiosity, they fuel it, pushing scientists and thinkers to explore ideas that once seemed far-fetched. In many ways, science fiction has been a catalyst for scientific progress, blurring the line between fantasy and innovation. But art isn't just about predicting the future or creating fantastical worlds. It's also a tool for understanding. When science presents us with concepts that are difficult to grasp, like the multiverse or higher dimensions, art steps in to make them tangible. Through paintings, sculptures, and even music, we can visualize the abstract, transforming complex ideas into something we can connect with on an emotional level. It's as if art gives us a language to speak the unspeakable. What if art and science, often seen as separate realms, could join forces to explore the unknown? Imagine scientists and artists collaborating to interpret the mysteries of the cosmos, each bringing their unique perspective to the table. Together, they could create a richer, more holistic understanding of the universe and its secrets. After all, both are driven by the same fundamental force, curiosity, and in that shared pursuit, they might just uncover something extraordinary. When we gaze up at the night sky, our eyes can only take us so far. It's technology that has become the bridge between human curiosity and the vast mysteries of the cosmos. From the earliest telescopes to the cutting-edge instruments of today, our tools have transformed how we see the universe and how much of it we can explore. Take the James Webb Space Telescope, for example. Launched in 2021, it's already revealed stunning details about distant galaxies, the birth of stars, and even the atmospheres of exoplanets. Its infrared capabilities allow us to peer through cosmic dust, uncovering secrets that were once hidden from view, but telescopes are just the beginning. Particle accelerators like the Large Hadron Collider are pushing the boundaries of what we know about the fundamental building blocks of the universe. By smashing particles together at incredible speeds, scientists are recreating conditions that existed just moments after the Big Bang. These experiments help us understand the laws of physics that govern everything from the smallest particles to the largest structures in the cosmos. And then there's the promise of quantum computing. While still in its infancy, this technology could one day solve problems that are currently beyond our reach. Imagine simulating the behavior of black holes or modeling the early universe with unprecedented precision. The question is, could technology one day reveal the ultimate secrets of the cosmos? It's a tantalizing possibility. Every breakthrough brings us closer to understanding the nature of reality itself, but the universe is vast and its mysteries are deep. As our tools evolve, so too does our ability to ask bigger questions, and perhaps one day find the answers. In the quest to unravel the mysteries of what lies beyond the observable universe, one truth stands out: no single field of study holds all the answers. Scientists, philosophers, and artists each bring a unique lens to the table, and it's through their collaboration that we inch closer to understanding the cosmos. Picture a cosmic orchestra where each instrument plays a distinct role. The physicist's equations harmonize with the philosopher's questions, while the artist's imagination adds depth and color to the symphony. Together, they create a richer, more complete picture of the universe's enigmas. This interdisciplinary approach isn't just beneficial, it's essential. Think about it. Science provides the tools to measure and observe. Philosophy challenges us to question the very nature of reality. And art helps us visualize and communicate concepts that are otherwise intangible. When these disciplines work in tandem, they unlock new ways of thinking and problem solving. It's like combining puzzle pieces from different boxes. Suddenly, the bigger picture begins to emerge. Take, for example, the concept of dark energy. Physicists can detect its effects on the universe's expansion, but philosophers ask, what does it mean for our understanding of existence? Artists, in turn, might translate these ideas into stunning visualizations that make the abstract feel tangible. This fusion of perspectives doesn't just deepen our knowledge, it sparks breakthroughs that might otherwise remain out of reach. Unity, then, might be the key to unlocking the universe's deepest secrets. When we bring together diverse ways of thinking, we create a tapestry of ideas that's stronger and more intricate than any single thread. This collaborative spirit reminds us that the journey to explore the cosmos isn't just about science. It's a collective human endeavor driven by curiosity, creativity, and the shared goal of discovery. What drives humanity to look up at the stars and wonder what lies beyond? The answer lies in something deeply embedded within us: curiosity. This relentless itch to explore, to question, and to understand is more than just a trait. It's a fundamental part of who we are. Think of curiosity as a cosmic spark, a tiny but powerful force that ignites our desire to venture into the unknown. It's the same spark that led early humans to map the heavens, that fueled the voyages of explorers across uncharted seas, and that now propels us to probe the farthest reaches of space. From an evolutionary perspective, curiosity has been a survival mechanism. Those who questioned their surroundings, who sought to understand the patterns of the natural world, were more likely to thrive. Over time, this inquisitive nature evolved into something greater, a drive not just to survive but to discover. It's what compels us to ask the big questions. Are we alone in the universe? What exists beyond the observable cosmos? These questions aren't just idle musings. They're the engine of progress, pushing us to develop new technologies, design groundbreaking experiments, and expand the boundaries of human knowledge. Consider the countless scientific breakthroughs born from curiosity. Galileo's observations of the night sky revolutionized our understanding of the cosmos. Einstein's relentless questioning of the nature of space and time gave us the theory of relativity. Today, our curiosity continues to push the envelope, from launching telescopes that peer billions of light years into the past to theorizing about the existence of parallel universes. Each discovery builds on the last, creating a tapestry of knowledge woven together by our innate desire to explore. But curiosity isn't just about science, it's about our place in the universe. It's what makes us dream of distant worlds and imagine civilizations far beyond our own. It's the force that keeps us searching, even when the answers seem out of reach. So, could curiosity be the key that unlocks the mysteries of the cosmos? Could it be the very thing that propels us into the unknown, guiding us toward discoveries we can't even yet fathom? Imagine a cosmic classroom where the universe itself is the curriculum and every discovery is a lesson waiting to be learned. Education plays a pivotal role in how we understand the cosmos and what might lie beyond the observable universe. It's not just about teaching facts or equations, it's about igniting curiosity, fostering wonder, and inspiring the next generation of scientists, explorers, and thinkers who will push the boundaries of what we know. Public outreach and accessible science communication are the bridges that connect experts to the wider world. When complex ideas are shared in a way that's relatable and engaging, they invite everyone into the conversation. Think of it as translating the language of the cosmos into something we can all understand and appreciate. This isn't just about making science easier to grasp, it's about empowering people to see themselves as part of something greater, as active participants in humanity's quest to explore the unknown. The impact of this approach goes far beyond individual understanding. By nurturing curiosity in young minds, we're laying the foundation for future breakthroughs. Every child who gazes at the stars and wonders what's out there could grow up to be the astronomer who uncovers a new cosmic truth, or the physicist who solves one of the universe's greatest mysteries. Education isn't just about the present, it's an investment in the future, a way to ensure that the torch of discovery is passed on to those who will carry it further. This connection between education and exploration might even hold the key to unlocking some of the universe's deepest secrets. By fostering a culture of learning and curiosity, we're not just preparing for the next big discovery, we're actively shaping the path that will lead us there. When it comes to exploring the mysteries of the cosmos, speculation isn't just a luxury, it's a necessity. The vastness of the universe, with its uncharted territories, demands bold ideas and imaginative leaps. After all, if we only stick to what we can observe and measure, we'd miss out on the countless possibilities that lie beyond our current understanding. Speculation acts as a bridge between the known and the unknown, pushing the boundaries of science and sparking curiosity that drives us forward. Take Carl Sagan, for example. His ability to weave complex scientific ideas with imaginative thinking inspired generations to look at the stars not just as distant objects, but as gateways to infinite possibilities. Sagan's work, like his Cosmos series, wasn't just about presenting facts, it was about encouraging people to dream big and question everything. Similarly, Stephen Hawking's theories about black holes and the nature of time were rooted in speculation, yet they opened up entirely new fields of study that continue to shape our understanding of the universe. This kind of speculative thinking isn't just about dreaming for the sake of dreaming. It's about creating a framework for exploration. Even if an idea can't be proven right away, it can still guide researchers toward new questions and experiments. Think of it as planting seeds. Some may grow into groundbreaking discoveries, while others might lead to unexpected insights along the way. The key is to keep wondering, keep questioning, and keep exploring. After all, isn't that how every great discovery begins, with a simple question? What if? Science thrives on curiosity, but it's skepticism that keeps it grounded. When we explore the mysteries of what lies beyond the observable universe, it's easy to get swept away by grand theories and speculative ideas. That's where skepticism comes in. It acts like a cosmic filter, sifting through the noise of speculation to separate the plausible from the implausible. Without it, we risk accepting ideas that sound compelling but lack evidence, essentially mistaking fiction for fact. Critical thinking is the backbone of skepticism. It pushes us to ask tough questions. How do we know this theory holds up? What evidence supports it? Are there alternative explanations? This approach doesn't just protect us from falling for pseudoscience. It propels scientific progress forward. By challenging assumptions and testing hypotheses, skepticism forces us to refine our understanding and uncover deeper truths. Take the multiverse theory, for example. It's an intriguing idea, endless universes, each with its own set of physical laws. But without skepticism, it could remain just that, an intriguing idea with no basis in reality. Skepticism demands that we probe deeper, look for evidence, and question whether this theory is a genuine insight or merely a product of our imagination. This rigorous process is what transforms speculation into science. So, while skepticism might seem like a roadblock to creativity, it's actually a guiding light. It ensures that our journey into the unknown is both bold and grounded. And who knows, it might be the very tool that helps us uncover the ultimate truth about what lies beyond the cosmos, whatever that may be. What is it about the vastness of the cosmos that stirs something deep within us? That feeling, often described as wonder or awe, is more than just an emotional response. It's a cosmic spark igniting our curiosity and propelling us to seek answers to the universe's greatest mysteries. When we gaze at the night sky, whether through a telescope or simply with our naked eyes, we're not just observing distant stars and galaxies. We're connecting with something far larger than ourselves, and that connection has the power to inspire both scientific discovery and artistic creation. Wonder has long been the driving force behind humanity's exploration of the unknown. It's what led ancient civilizations to map the stars and modern scientists to build space telescopes that pierce the veil of the observable universe. This sense of awe doesn't just fuel curiosity, it transforms it into action. It pushes us to ask questions that might seem unanswerable. What lies beyond the cosmic horizon? Are we alone in the universe? What does it all mean? These questions aren't just intellectual exercises. They're a testament to our innate desire to understand the cosmos and our place within it. But wonder isn't confined to the realm of science. It's also the wellspring of artistic expression. From the breathtaking visuals of space photography to the haunting melodies of music inspired by the cosmos, wonder bridges the gap between the analytical and the emotional. It reminds us that the universe isn't just a place to be studied, it's a source of beauty and inspiration. Artists, writers, and musicians have long drawn from this well, creating works that capture the profound sense of awe we feel when confronted with the infinite. Psychologically, wonder has a unique ability to expand our perspective. It shifts our focus from the mundane to the extraordinary, reminding us of how small we are in the grand scheme of things, yet how deeply connected we are to everything around us. This shift can be humbling, but it can also be empowering. It encourages us to dream bigger, to push boundaries, and to embrace the unknown. In a way, wonder is the ultimate motivator, a force that drives us to explore not just the outer reaches of space, but the inner reaches of our own potential. So, could it be that wonder is the key to unlocking the mysteries of the cosmos? Could this profound sense of awe be the force that compels us to venture into the unknown, to ask questions that have no easy answers, and to seek understanding in the face of the infinite? The next time you look up at the night sky, let that cosmic spark ignite your imagination. Who knows where it might lead? The human mind has an extraordinary ability to wander beyond the edges of what we can see, to dream up possibilities that stretch far beyond the limits of our observable universe. Imagination is more than just a tool for daydreams. It's the spark that ignites scientific discovery and artistic creation. When we look into the vastness of space, we're not just staring at stars, we're asking questions about what might lie beyond them. What could be out there in the darkness we can't yet measure? Imagination steps in to fill that void, offering us a cosmic playground where ideas can roam freely. Think of it like this: if the universe is a vast, uncharted ocean, imagination is the compass that guides us toward uncharted islands of thought. It's what allowed Einstein to envision curved spacetime, and artists like Vincent van Gogh to translate the night sky into swirling masterpieces. Without imagination, we'd be stuck staring at the shore, never daring to set sail into the unknown. It's the bridge between what we know and what we can only begin to wonder about. This creative force doesn't just belong to scientists or artists, it's a part of everyone's mental toolkit. When you gaze up at the night sky and wonder what might exist beyond the farthest galaxies, you're tapping into that same boundless curiosity. Imagination invites us to ask what if, and then to chase those questions, whether through equations, stories, or art. It's the key that might one day unlock the cosmic mysteries we're still struggling to understand. So what if the answers aren't just waiting to be found, but are waiting to be imagined first? Throughout human history, hope has been the invisible thread weaving through our greatest endeavors, and the exploration of the cosmos is no exception. It's this very hope, this unshakable belief that there is more to uncover, more to understand, that drives us to push the boundaries of what we know. Think of hope as a cosmic light gleaming faintly in the vast darkness of the unknown. It doesn't reveal everything at once, but it guides us step by step toward answers we've yet to imagine. On an emotional level, hope transforms the way we approach the mysteries of the universe. It turns overwhelming questions into thrilling challenges and transforms the daunting scale of the cosmos into a canvas of endless possibilities. When scientists stare into the depths of space, they're not just searching for data or evidence. They're fueled by the belief that discovery is possible, even when the odds seem insurmountable. This isn't just optimism, it's a psychological anchor that keeps us grounded amid the uncertainties of scientific inquiry. Consider the immense challenges of studying what lies beyond the observable universe. The distances are incomprehensible, the theories are complex, and the tools we have are still evolving. Yet hope persists. It's what keeps researchers tirelessly analyzing data, designing experiments, and refining models, even when progress feels slow or elusive. Hope reminds us that every breakthrough, no matter how small, brings us closer to understanding the cosmos in ways we once thought impossible. But hope isn't just a personal motivator, it's a collective force that unites us. It's the shared anticipation that drives humanity to build telescopes, launch probes, and dream of traveling to distant stars. It's the spark that ignites curiosity in the next generation, inspiring young minds to ask, what's out there? And how can we find it? In this way, hope isn't just a feeling, it's a catalyst for progress, a bridge between the known and the unknown. So, could hope be the force that propels us into the unknown? It certainly feels that way. It's the intangible energy that keeps us looking up at the night sky, asking questions, and daring to dream of what might lie beyond the edges of our understanding. In a universe full of mysteries, hope is the light that keeps us moving forward, one discovery at a time. As we reach the end of this cosmic journey, let's take a moment to reflect on the extraordinary theories we've explored. From the multiverse, where infinite versions of reality might exist, to the simulation hypothesis, which suggests our universe could be an intricate digital construct, each idea challenges the very nature of what we consider real. The holographic principle adds another layer, proposing that our three-dimensional world might just be a projection of information stored on a two-dimensional surface. And let's not forget cosmic inflation, which hints at a universe expanding far beyond what we can observe. These theories don't just push the boundaries of science, they invite us to question the fundamental fabric of existence itself. What does all this mean for us? It's a humbling reminder of how much we still don't know. The universe, in its vastness and complexity, holds mysteries that might forever lie beyond our grasp. Yet, that's what makes this exploration so thrilling. Each unanswered question is an invitation to dream, to theorize, and to keep searching for answers. Whether you're drawn to the idea of parallel universes or fascinated by the possibility of living in a simulation, these concepts remind us that reality is far stranger and more beautiful than we could ever imagine. To close, let's reflect on this thought from Carl Sagan. Somewhere, something incredible is waiting to be known. The universe is full of wonders, and every discovery brings us one step closer to understanding our place within it. But the journey doesn't end here. What are your thoughts on these mind-bending theories? Do you think we'll ever uncover the truth about what lies beyond the observable universe? Share your ideas in the comments below. I'd love to hear your perspectives. If you enjoyed this deep dive into the cosmos, don't forget to subscribe and hit the notification bell for more thought-provoking content like this. Together, let's keep exploring the mysteries of the universe, one theory at a time. Thanks for watching, and remember, the universe is vast, but our curiosity is even